Okay, so revision, accidents and collisions. First things first, formulae. Important, need to know how to use them. Then we have Newton's laws. We have some problems. And then finally, we're going to talk about car safety. Okay, so speed, distance, time, which we use these symbols for, SDT, right? So the best way to remember the formulae that we use when calculating speed, distance and time is to remember the triangle. STD, okay? So what this triangle tells you is that speed equals d over t, we've already done, not S, let's try again, d equals S times t, so distance equals speed times time, and time equals distance over speed. Right, so remember that it depends on the units that you are looking for in your answer. So for example, if I'm looking for speed in meters per second, but I have my distance in kilometers, then I need to convert this to meters. If I have my time in hours, I have to convert this to seconds because I want my answer in this form here. I want this to be my units, right? So, for example, if I want to work out the speed and I want my answer in meters per second, and I travel 1 kilometer. I convert this to meters, so I've got 1,000 meters, and my time is in hours. So I travel 1 kilometer in 1 hour because I'm really slow. So I have to convert this hour to seconds. So I times that by 3,600 because there's 3,600 seconds in an hour. So then I have 3,600 seconds. So my speed will equal 1,000 meters divided by 3,600 seconds. And that will give me an answer in meters per second. So that equals to about 0.28 meters per second if I round it up to 2 decimal places. Okay, so now if we look at the difference between distance and displacement. So distance measures the actual distance travelled. So for example, if I start at this cross, go down 4 meters, go across 4 meters, go up 4 meters, so just say I'm walking around the block, go back to my start point, another 4 meters, my total distance travelled is 16 meters. Displacement, the difference between distance and displacement is that displacement actually looks at how far you ended up from your starting point. So if I started here and I did the same thing, so 4 meters, 4 meters, 4 meters, 4 meters, I've actually ended up in exactly the same spot that I started from. So my displacement is actually 0. Because I've finished, even though I've travelled 16 meters in total, I've actually finished in exactly the same spot where I started. Okay, so now we're going to look at the difference between speed and velocity. So speed is how fast. It's basically how fast you're going. Velocity is the same thing as speed, but we're looking at how fast you go in a particular direction. So for example, if I'm travelling in a car, I say that my speed is 13 meters per second, right? But I might be travelling in a northerly direction, so my velocity would be 13 meters per second north. So basically the difference is speed just looks at how fast you were going, and there's two different types. There's the average speed, which tells you how far it travelled over an extended period of time. So generally we're calculating the average speed because we're assuming that an object is not really staying at a constant speed the whole time. So for example, if you're driving in a car, you have to slow down for traffic lights, you have to slow down for a roundabout, your velocity might change, you might have to brake because somebody in the car in front of you brakes. So we're looking generally at your average speed. When you look down at the speedometer in front of you, so the little scale thing with the numbers on it, that is called your instantaneous speed. So that is your speed at that particular instant in time. This here is your instantaneous speed. So velocity, the difference between the two of them is that velocity gives you a direction. So we're talking about how fast you're travelling with displacement. Okay, so if we look at this example here, so we've got Fred who's going hiking. So Fred left base camp and headed east and walked 4 kilometres in the first hour. So what you do is you start from 0, so it took him 1 hour to walk 4 kilometres. So you just get your thing and draw a straight line. You should be using a ruler to do this, okay? And then he stopped for 30 seconds. So we go across for 30 seconds. And then he walked west for 30 minutes, covering 1 kilometre. So basically what west means is that he went back. If he was going east before, so if he was going this way before, now he's gone back a little bit. He's gone west. So, downward sloping line, he's gone west for 30 minutes, covering 1 kilometre. So like that. So now we're at the 2-hour point. So then he's turned east and he's walked 3 kilometres in 1 hour. So we were at 3, so he's travelled 3 kilometres, so we're going up. And now we're at hour 3. He then stopped and rested for 30 minutes, going across again, and then walked back to base camp in 1.5 hours. So in 1.5 hours, it takes us to 5 hours. And the distance from the starting point, we're going back to 0. So then we got to calculate the speed of his walk. So in the first bit, if he walked 4 kilometres in the first hour, he has to have gone 4 kilometres per hour. Direction, east. Here, he's not moving, so we got 0. So I'm using V instead of S to indicate velocity, because velocity, remember, we're looking at distance and direction. So here we've got distance and direction, so we should be using V. So then he's gone west for 30 minutes. So he's gone 1 kilometre in 30 minutes. So it's 1 divided by 0.5 hours. So he's gone 2 kilometres. His velocity is now 2 kilometres per hour west. This way here, going up here, has to be 3 kilometres per hour, and he's gone east. Again, we're not going anywhere, so V is 0. And then he's walked back to base camp, so he's walked 6 kilometres in 1.5 hours, so his V is 4 kilometres per hour, and he's gone west. So, as you can see, when you look at a graph that's talking about the motion of an object or the directions that an object is travelling in, if it's a straight line, we're talking about no change in speed or rest. If we're looking at this bit here, this tells us that we're travelling, we're moving forward over time. Whilst this is also moving, we're not moving in a forward direction. We're still travelling, but because we're looking at the direction that we're travelling in as well, we've got a downward sloping line. The displacement of Fred is 0 because he started at base camp and he's ended up at base camp. Irrespective of the fact that he's travelled all of this distance, his actual displacement is still 0. So the next thing that we're going to look at is acceleration, and acceleration is the change in velocity. So the triangle symbol here that we're looking at, that is the mathematical symbol to indicate a change in something. So acceleration can be positive or negative. When we talk about negative acceleration, we're talking about deceleration. So the units that we use to talk about acceleration is meters per second squared. And if you see a negative value, so say it's a -5, for example, meters per second squared, this negative symbol indicates deceleration. So it indicates that the vehicle or the object or whatever we're talking about here is actually slowing down. So the formula that we use to talk about acceleration is A equals V minus U over T. So V is your final speed or your final velocity, and U is your initial. And T, of course, is over time. So, if, for example, I was in a car and it went from 5 meters per second, it was travelling 5 meters per second, and it sped up to 15 meters per second. And it did this over a period of 5 seconds. So my acceleration, using the formula V minus U over T, equals 15 minus 5 over 5, which equals 2 meters per second squared. Now if I do another example, so say I was in that same car and then that car then went from 15 meters per second and then it braked. So if it's braking and it comes to a complete stop, then its speed is 0. It's not moving anywhere, it's stopped. So it does this in 5 seconds again. So my acceleration, I'm still using the same formula, nothing's changed, is 0 minus 15 divided by 5. So now my deceleration, or my negative acceleration, using a negative sign, is 3 meters per second squared. So often in exams like this, we might ask you to rearrange an equation and try and work out one of the other variables. So for example, in this equation, say if we want you to work out the V, the final speed or the final velocity, you need to know how to rearrange it. So V equals U plus AT. Another equation that you might need to use that we didn't really talk about in class, but it could be handy to work out the distance that an object or a car is travelling in over time. If you don't have time to draw up a graph and work out the area underneath the curve, then a formula that you can actually use is S, where S is the distance. It's a capital S, not a little s like we're normally using. UT, so U is still initial speed. and t is still time, plus half at squared. So, if I give where a is acceleration and t is still time, obviously. So if I give you an example, so say I am in a boat and it's travelling at a speed of 5 seconds. It accelerates at 1.5 seconds for 20 seconds. So first I want to know what v is. So v equals u plus a times t. So this is my my u, sorry. This is my a. And this is my t. So v equals 5 plus 1.5 times 20. And that gives you an answer of 35 meters per second. Because remember, v is velocity, so it's in meters per second. Now say I want to take that and I want to work out the distance that this object covered whilst it was accelerating. So my v is 35, my u is 5. These are both in meters per second. And then my t is 20 seconds. And my acceleration, is 1.5 meters per second squared. Right, so S equals ut plus half at squared. So what I have is I have 5 times 20, which is 100, plus half times 1.5 times 20 squared. So what I have is 300. So my total distance travelled, or my S, is 400 meters. And the other way I said you could do it before is to draw up a graph. So that's my graph. And then you work out the area underneath the graph. So you just break up the graph into shapes that you know and use the formulas that you would already know. So formula for the area of a square, for example. And just look at the units along the x and the y axis and work out the distance between the points and then just add all of those up together.